All right, so good afternoon, everyone. All right, so we are given this question and we are asked to find the length AB. Now, anytime you're given a question like this, you have to first identify what you're working with. So I have a right angle, and you know, when it comes to right angle, triangles, and trigonometry, when it comes to trigonometry, it could either be a right angle or a non-right angle triangle. If it is a right angle, we have two options. The first one, which is Pythagoras theorem, where they give you only sides. So they give you two sides and ask you to find the third or the missing side. While SOHCAHTOA, it's where one angle is considered. So it's either they give you that angle or they ask you to find the sides of a missing angle. So if you're given a question like this one, and they asked us to find AB, your first step is to determine your rule. Determine which of the two rules, as it's a right angle triangle, that you're going to use. Right, so it could either be Pythagoras' theorem, or SOHCAHTOA. Now, your first step is you have to ask yourself which one, right? Now, once they give you an angle, once an angle is given, or if they ask you to find an angle, the size of a particular angle, once angles are considered, we have to use SOHCAHTOA. Right? So you determine your rule, and we've decided I'm given an angle, so it's going to be the rule on SOHCAHTOA. Your next step is that you are going to label your sides. Good afternoon. All right, so your next step is we're going to label the sides. Your hypotenuse is always the easiest one to identify. And the reason for this is because it's the longest side of your right angle triangle, and two, it's always facing or opposite your right angle, right? So this here is going to be your hypotenuse. The angle which is opposite the angle that is given, or they ask you to find, the side opposite to that is known as opposite. And then your third side is the adjacent. Now, after you've labeled your sides, you want to see which ratio you're going to use. Right, so which of the following will be used? So Is it sine? Remember, the so means sine is equal to opposite over hypotenuse. Ka means cos is equal to adjacent over hypotenuse. And tangent or toa, tangent or tan, we also call it short tan, is equal to opposite over adjacent. So you have to see which of these three you're going to use. And in order to know which of the three, you have to see which two sides are involved. Right? So look at this. So they gave you this length here. Now that's the opposite. And they asked you to find AB. Right? So they gave us this and asked us to find this. So the two sides which are being considered in this question would be the opposite and the adjacent. So the two sides involved will help us to determine which of the three ratios we're going to use. And in this case, it's going to be tan. Now, anytime you're using this formula, it's always tan of the angle. This symbol is theta, and it represents an unknown angle. You know how with algebra we use x to represent an unknown letter? This represents an unknown angle. So it's always tan of whatever is the angle, and tan is opposite over adjacent. So the angle, they gave us the angle as tan of 48 degrees is equal to opposite. Your opposite is 4 centimeters divided by the adjacent. And the adjacent is what I'm trying to find. So it's going to be x. So let's work this out. We're using our calculator. So you use a calculator and you figure out what is tan of 48. Tan of 48 is, I got 1.11061, but I rounded it up to 2 decimal places. Now, I want to know what is x. So I want to get x on one side of the equal sign. So you could do cross multiplication, or you can do what I like. I like to carry everything across the equal sign. I'm carrying the x across here because I can't free this 4 unless I remove the x. So I'm going to bring it across, and because that x was divided, when it goes across, it's going to become multiplying. So I'll have 1.11x is equal to 4. And then remember, I want x alone. So now I'm going to carry this across because I got this 4 alone, right? I wanted to release it or free it. So when I carry across this, I'll have x alone on my left-hand side. So I'll have 4, the 1.11 was multiplying. So when it goes across, it's going to become divided. So we'll end up with 4 divided by 1.11. Just a second, huh? I think my calculator is in read. One second, huh? Let me just double check my calculator. All right, no, it's actually correct. So I got tan of 48 was 1.11, and then 4 divided by 1.11, and I got 3.6. Right, so I got my length of AB as 3.6 centimeters. Now you guys can use your calculator as well and check it and see. Make sure you guys got the same thing. All right, so for this one, they gave us to find the unknown angle X. Now your first step, remember in your steps, there's a decision to make. You have to determine, as it's a right angle triangle, are we going to use Pythagoras theorem or are we going to use SOHCAHTOA? Now in this case, there is an angle being considered, whether they gave you the value or they asked you to find the value of it. So in this case, because an angle is being considered in the question, we are going to use SOHCAHTOA. After you've considered which of the two rules, your next step is to label the sides. So on your right angle triangle, you label what you have. Remember, opposite the right angle or the longest side is always your hypotenuse. The side opposite the angle, that's called your opposite. And on the third side, it's the adjacent. So they gave us two sides, the opposite and the hypotenuse. So you ask yourself, which of these three ratios would I use if I'm considering the opposite and the hypotenuse? The one which has the opposite and the hypotenuse is the sine. So it's going to be sine always of the angle, but this time my angle is x. Is equal to the opposite over the hypotenuse. So sine of x, I'm trying to find x, is equal to the opposite. Opposite is 3 divided by the hypotenuse, which is 6. Now our goal is to find out the value of x. So using my calculator, I'm going to divide 3 divided by 6. Right, and 3 divided by 6, that's 0.5. But in algebra, anytime I want to find the unknown letter, I could carry everything else across the equal sign and perform the opposite operation. So we'll have x is equal to the opposite of sine is sine inverse. So when I carry across sine, I'll get sine inverse. If I carry across cosine, I'll get cos inverse. If I carry across tangent, I'll get tan inverse. So as I'm carrying across the sine, the opposite of sine is sine inverse. So I want to find out what is sine inverse of 0.5. On your calculator, you're going to have second function or shift. So you press second function, or if you have shift, you press shift. Then you press sine, and then you put in your 0.5, and that will give you your value. Check it with me and tell me the answer you got. So punch in sine inverse, that shift or second function, and then sine, and then you put in your 0.5. All right, and we're supposed to get 30 degrees. So we'll get that x is 30 degrees. All right, so we got that x is equal to 30 degrees. Now, anytime you have right angle triangles, and you are considering which rule it is, remember, once it's a right angle triangle, one of two rules. If they give you two sides and ask you to find a third side, you're going to be using Pythagoras' theorem. And remember, Pythagoras' theorem is where you have your hypotenuse squared is equal to the sum of the square of the other two sides. If it is that an angle is considered, you know you have to use SOHCAHTOA, and you must label the sides of your triangle in order to identify which of the three ratios you're going to use, whether it's sine, cosine, or tangent. And then, depending on the two sides that are being used or considered within the question, that is going to determine which of the three you'll use. All right, so looking at the topic of indices, exponents, power. Now, all of these, it means the same thing. Some questions or some books, they might use indices. Some books, they might use exponents. And some books, they might use power. But just like, the fruit avocado, some people might call it avocado, some people might call it zavoka, but it's the same fruit. It doesn't matter which one you see, it's the same thing we're talking about. Now, let's say they gave us this. This number here They call that number the base. This number up here, they call that the power or the exponent or the index. Index is the singular of indices. And what it does is that it tells me the number of times, right? So the power or the index or the exponent tells the number of times we have to multiply the base by itself. Right? So the power or the index or the exponent is telling me how many times to multiply the base by itself. So this is telling me that I have to multiply the base, which is 5, by itself 2 times. If they ask you to find the value or to solve it, you have to work it out. Right? So 5 5s are 25. So if they tell you find the value of it, you work it out. Let's say they gave you this one. My base is 5 and my power is 3. So that is telling me I have to multiply my base by itself 3 times. So it's going to be 5 times 5 is 25. And then 25 times 5. Right? That's how it goes. Right? So it's 5 times 5, which is 25. And then times 5 again. 25 times 5 will be 125. So anytime they ask you to calculate or to solve or to find a value, this is what we do. If they gave you something like this, this means my base is 2. So it's going to be 2 by 2. So it's going to be 2 by 2 by 2 by 2, 5 times. One, two, three, four, 5. And this is how we multiply. 2 2s are 4. 4 2s are 8. 8 2s are 16. 16 2s are 32. So it's always when you multiply the solution or the product of the ones before, then you multiply it again. Now, if you are using your calculator, on your calculator, if you're allowed to use the calculator and they ask you to solve it, on the calculator, you're going to see either x to the power of y or y to the power of x or a symbol like that. If it's on the button itself, just press the button. But if it's on, like painted on the calculator, like you have a button here and it's painted above, in order to get it, you have to press shift or second function in order to get it. So if you were asked to find it, to calculate it or find the value of it, you can simply put in 2 Then press that knob and then the power, and you'll get your answer. Aidan, you could try it. You guys can try it. Right, so this is if they ask you to find the value. So let's say they asked us to find the value of this one. So if they asked us to find the value of this, you know 8 cubed is 8 by 8 by 8 times 9 squared is 9 by 9. If you are allowed to use your calculator, on your calculator, you'll put 8, your function key, and then 3. So you could try it and see. If you're not getting it on your calculator, if you're not getting the same answer as I am, then you have to let me know. Right, so it's going to be 512, 8 cubed. And then you're going to multiply that by 9 squared. 9 nines are 81, we should know that. So we'll end up with 512 times 81. And we'll end up with 41,472. You guys could double check on your end. Now that's if they ask you to solve it, calculate the value of, find the value of. Right, so this part here is solving. Now, I'll put it right on the side here. If they ask you to simplify, simplifying is different, right? Solving is when you ask for the answer, but simplifying is different. So let's say they ask you to simplify. Now, in simplification of indices, we have some rules. All right, so the first rule is, let's say they gave you 2 cubed times 2 to the power of 4. Now notice they never said to solve or to find the value of, nor to calculate. They said to simplify. So that means they want to reduce it into a form where it's just one single number in index form. Now there's a rule that says once your bases are the same, right? So my bases are the same, and you're multiplying, right? So if you have same bases being multiplied, same bases being multiplied, then that's going to be where you add the powers, right? So anytime you have the same base, you just add the powers, that's all. right? So you see how we have 2 to the power 3 times 2 to the power 4. All we have to do is just add the 2 powers. Remember, your powers will be 3 and 4. So I add the 2. 3 plus 4 is 7. So if I had to simplify this, I'll get 2 to the power of 7. Now let's explain that in another way. Isn't 2 cubed the same as 2 by 2 by 2? Multiplied by 2 to the power of 4. 2 to the power of 4 is not 2 by itself 4 times. 1, 2, 3, 4. So when I multiply this, I'll end up with 2 by 2 by 2 by 2 by 2 by 2 by 2, which is the same as 2 to the power of 1, 2, 3, 4, 5, 6, 7. So instead of doing this, we understand that only if the bases are the same, you just add the powers. Only if the bases are the same. So like for these two, the bases are different. So I can't add them. All right, so rule number 2 is if your bases are the same, and they are being divided, so same bases, right? So same bases being divided, we're going to subtract the power. All right, so let's say they gave us one like this. So they gave you 4 to the power of 5 divided by 4 to the power of 2. Now, that division is the same as me putting it like this, okay? So if you have it like this or like this, it's the same thing, right? You have to understand that either way you see it, they are both divided. Now, 4 to the power of 5 is actually 4 by 4 by 4 by 4 by 4. So multiplying it by itself 5 times. And then 4 to the power of 2, or 4 squared, is the same as 4 by 4. Now, with respect to fractions, we could cancel both top and bottom once we have common factors. So we'll be left with 4 by 4 by 4, which is the same as 4 to the power of 3 over 1, or just 4 to the power of 3. Now, instead of doing this, because if you have larger numbers, it could become torturous. Once your bases are the same, all you do is you subtract the powers. Right? So the powers will be 5 minus 2, and 5 minus 2 is 3. So if they ask you to simplify and you're dividing, all you do is you subtract the bases. Next law. Right, so the next rule is Let's say they gave you one like this. A to the power of m, and then you raise it to the power of n. Once it is like this, all we do is we multiply the two powers. So it'll be m times n, which is mn. So for example, so this is rule number 3. So let's say they gave you a to the power of 4 squared. Anytime it's raised to power in this form, you're going to multiply the two powers. It will be 4 times 2. So it's going to be a to the power of 4 twos are 8. Rule number 4. Anything raised to the power of 0 is 1. Anything. It could be 1,000,000 or 1,000 to the power of 0. It's 1. It could be a to the power of 0. It's 1. It could be b to the power of 0. It's 1. It could be a times b to all to the power of 0. That's 1. Anything raised to the power of 0, it's 1. Right? Next rule, anything raised to the power, anything raised to the power of 1 is itself. So a to the power of 1 is a. 100 to the power of 1, it's 100. B to the power of 1, it's b. Your rule is anything to the power of 1 is itself. All right, so let's look at some questions so far. Let's look at some ways in which you could bring the so far. All right, so let's say they gave you 2 to the power of 5 So anytime you get a question like this, you break it up. So I could look at my numbers on the top first. Let's say they ask us to simplify this. Remember, if they ask you to simplify, you're using these rules to make it into a singular index form. But if they tell you to solve it, you have to find the value of it. So for this one, it says to simplify. Bases are the same, and we're multiplying. once bases are the same and we're multiplying, your base remains the same. And then you add the powers. So it's going to be 8 plus 5, 8 plus 5, 8, 9, 10, 11, 12, 13. So that's 2 to the power of 13 divided by 2 to the power of 10. Bases are the same. Once the bases are the same and you're dividing, you could simply subtract the powers. So 13 minus 10 is 3. So I'll be left with 2 to the power of 3. Now, what if they gave us one like this? So they gave us this one. So we're going to simplify what's on top. Now, if it doesn't have a power, you understand that it's 1. So if the number doesn't have a power, remember anything raised to the power of 1 is itself. So if it doesn't have a power, we understand that it's 1. So once my bases are the same, I add the powers. So I'll end up with a to the power of 7 plus 1, which is 8, divided by 8 to the power of 9. Now watch this part. Once I'm dividing and my bases are the same, I subtract the powers. So I'll have 8 take away 9. And you know, according to your rules, you have to make sure that you also know your rules when it comes to positive and negative numbers, okay? The rule is once you have two different signs, you subtract and keep the sign of the larger. So 8 minus 9, that will be -1. So we're seeing that we have negative powers. Now, what does negative power mean or negative index mean? All right, so once you have a negative index, it's actually the reciprocal of the base. All right. So anytime you have a negative power, in a case like this, it means that you have to find the reciprocal of the base. So in this case, A is my reciprocal. A is my base. A over 1 is what it actually means. So the reciprocal of this will be the flip of it. So my reciprocal will be 1 over A. So anytime you have a negative power, you have to find the reciprocal. And reciprocal simply means if I have 5, 5 is also known as 5 over 1. The reciprocal of that will be 1 over 5. If they gave us 1 over 6, the reciprocal of 1 over 6 will be 6 over 1. If they gave you 2 over 3, the reciprocal of this will be 3 over 2. So basically, the reciprocal is where you flip the fraction. And then you raise it to the same but positive power. All right, so let's look at some examples. So if they gave you 5 to the negative 2, my base is 5. So when I flip it, it's going to be 1 over 5. And I'm going to raise it to the same but positive power. Right? So instead of negative 2, it's now going to be to the power of 2. If I gave you 2/3 to the power of negative 6, the negative sign means I'm going to find the reciprocal of my fraction, which means I flip the base. And it's going to be raised to the same but positive power. And when you have a fraction being raised to a power, it's actually the top to the power of that divided by the bottom to the power of the same power. All right, so here's what I'll do. I'll pause here for today and we'll continue next class.